For this session, we are going to kind of primarily look at how do you modernize your applications. Again, for my introduction, I have been with AWS for a couple of years. My name is Mahesh Gurram. I'm a senior solution architect at AWS. And in this session, I want to concentrate primarily what are the challenges that you need to migrate your existing workflow, and what are the risks as well, right? As government agencies with a lot of new ransomware. I think we had a discussion with Checkpoint earlier, and we had Jim talk about RPA. But when you think about some of your existing applications, you want to think about how do I scale that application, right? We will talk, and because end of the day, your customer experience in this case, it is citizens experience. You need to have a great citizen experience, as Jim was talking about having the new generation citizenships are expecting it to be all digital. So there are certain expectations with everything being digital. And these monolithic applications are these applications that were developed few decades ago, which are right now to be modernized, right? What do you do with that? Do I just go ahead and purchase a new set of appliances to kind of support this monolithic? Or there are a lot of decisions and stuff that go on in federal agencies, and there are a lot of parameters, all the way from budgeting to compliance to regulation that you want to think about. So basically, we are going to talk about how we can do that process and how AWS can help you with that migration, and also suggest to you in the process some of the best practices that we have seen within the industry. So as I said, the way you look at it is you have this major monolithic where everything sits in this huge server or huge system, but the challenge there is it cannot like really scale up as much as you want, right? A good example in this case could be, let's say you have a website, right? Let's take the example of something like a CDC website. So pre-COVID, CDC was having good number of hits for people to find out information about different health related stuff. But once COVID hit, it was the relevant information. So not only citizens, now media outlets started to reach out and started to access this web server. And at once, the overall volume, or at once the number of hits onto CDC increased by 20 to 30 times just within a span of few days once back in, I think, March 2020, once COVID started to pick up. And it has been that way, right? So things like that. So if you have a monolithic system, scaling it up to handle that kind of traffic within a very small short time is not possible, because you only can increase your vertical scaling to certain points. So you can only have certain amount of CPU cores or certain amount of stuff. So at that point, you're having bad experience for your citizens if they are not able to get that relevant information. Again, CDC is just one example, but you have very similar examples with FEMA and when IRA hurt and stuff like that, right? So again, the other biggest challenges are everything that we do in something like this that you're seeing on the screen is extremely tightly coupled, right? So in this case, for example, your virtualization service, right? That could be that is extremely dependent on your app service. So if something goes wrong in your app service, or if for whatever reason a relational database is down, your entire app is down, your website is down, which is like really bad situation to be in. You definitely do not want to be in that kind of situation. And a few of the primary limitations why you want to, kind of think about re-modernizing the entire existing application stack, which are monoliths, are primarily, again, as we talked about, hard to scale. And we just talked about cannot handle failure, right? For example, because it is a monolithic and you're basically having a database, and that's it. For whatever reason, everything fails all the time. You have to plan for that. And if suddenly your database engine fails, or when IRA stuck, if there was a data center where the database was unable to access, how do you handle those failures, right? At that point, that is when your citizens are expecting data to be real time, expecting suggestions or expecting guidance federal agencies, and if you're not available that time because of whatever reason, and they are expecting everything to be in through apps, right? That is another thing. And the other main thing is, again, I think it is a slow deployment process. So a good example could be, let's say there is a update in the relational database we saw in our earlier slide. You upgraded the version. The overall amount of effort that you put in development of developing that upgrade or testing that upgrade and the regression testing is so high that a lot of agencies and a lot of commercial projects as well, they try to put it aside because of the cost involved in regression testing, cost involved in the risk against it. So things like that are limiting. Basically, because of that, you are kind of getting limited on what you can do in your uh, with your application. And finally, we also have like limited options in the sense that because of everything, for example, if you are on a certain operating system, you are not able to upgrade into some of the newer features, right? A lot of us use different kind of smartphones, and it is very similar to that. Is after a certain point, your apps do not get upgraded because the hardware is no more capable of handling that kind of stuff. So so these are kind of some of the limitations that you are kind of thinking about when you're thinking about your modernizing applications. So again, I think I talked a bit about this in my earlier session on time to market. That is extremely important, especially with the changing world. And so everyone is expecting like a good example could be in like about a decade ago, the number of smartphones were not huge, but within about 1 decade, you have seen the number of smartphones and number of apps explode. So everyone today is expecting every federal agency or even local counties to have some kind of app so that people could interact and have that kind of interaction, because not a lot of people are not really thinking about going on to the website, especially mini. So you want to kind of think about that on with the disrupting technology coming and disrupting everything that we know within a span of few years. You want to think about how do I design my system such a way that even if I get a newer technology tomorrow, it should be able to adapt to that rather than having something like a monolith, which we cannot do that. Again, and hyperscaling, I talked about it. I don't think I can signify how important it is, especially for federal agencies to scale. It might not be needed every day, but when that moment comes in, you should be in a position to scale enough to support all the demand and answer all those queries that we are seeing. And we also talk about technologically independent. What we mean by that basically is you don't want to basically lock yourself into whatever technology you are. You want to keep your options open in the sense if there is a right tool for the right purpose, you want to use that, right? For example, if you want to yeah, if you want to use Python or if you want to use RPA for a certain piece of your, and you think that is the right tool, that should be enabled, or you should have the capability, or you should select a vendor that supports that kind of right tooling as for the right solution kind of approach, and then have the capacity to tie everything together. And that is one of the reasons we are seeing a lot of movement into that microservices architecture. Again, one of the we talked a bit about Lambda earlier, but also we talked about challenges, right? So you cannot just take a huge monolithic application which runs 24 by 7 and put it into one very small Lambda, or put it into a bunch of Lambdas even, because there is so much complexity that is involved in this monolithic, that it has specific memory needs, it has specific storage, and also there is this specific environment you like to develop in. Because if you think about how these systems evolved over a few decades, we had initial requirements, and then you have a project, and the project evolves, right? So you have added requirements one on top of another, and now when you start to look at those requirements, no one really has a good idea about what exactly are we trying to achieve, because some of those requirements are buried within so many different documents that it is tough for even people to the SMEs to understand, and people leave or retire, and it is going to be extremely tough for you to even make a very small change to some of these applications. So at Amazon, the way we handle this, or whenever we talk about modernization, is what we call a 6R approach. Basically, we think about rehost, repurchase, retire, and retain. Right. I'm not going to touch much on that, but rehost is where you just take your existing application and host it in a totally different environment. Repurchase is trying to see if you can, rather than just purchasing it from a one place, trying to purchase. If you're, for example, doing a procurement system, trying to see if there is a new procurement system in the cloud that can support your needs, right? Retire is you think, okay, we might not need this anymore, and you kind of completely retire the technology. For the scope of modernization, primary things that we look at is replatform. What we mean by that is take your existing platform, take your application on whichever technology you have, take that environment and try to see how it would look like when you move it into a new platform, right? And also, while doing that, try to see if we can modernize that entire infrastructure. So we have few options within AWS we will talk about. So that is kind of replatforming. So you can take something as is, take an image of what you have today, and put it on AWS as your first step, replatform it, and then start to think about how do I modernize it. So the refactor is where we call rearchitect, right? So now you know what your existing system does, and then basically you're going to start to see how can you dissect that, or how can you break that monolithic into smaller pieces, so that now you're going to not only moving into the cloud, but also trying to see if you can take advantage of being in the cloud, right? A good example could be scaling. A good example could be having automatic deployment, which we call continuous integration, continuous deployment, and have a fully automated life cycle, right? So pretty much, pretty much these are the two things for modernizing. Again, if you have not had a chance, we have a very well published white paper about our 6R view. I think it's about 30 pages, and I strongly recommend anyone who is thinking about modernizing on going through the 6R approach. Again, it has nothing to do with AWS. Maybe you'll find very few jargons here and there for AWS, but it gives you a good idea about how you want to think about when you're thinking about modernizing any new applications. So the first step as part of that, as you're migrating from something like modernizing your application from some huge monolithic into something more of a microservice based architecture, you want to think about statelessness. So basically, statelessness is when you are not dependent on the same, when you don't have to remember the state of communication between two systems, right? So, for example, when you're logged into a website, cookies are used for you to track who is logged in and whether they are authenticated and stuff like that. On the processing side, you basically use the keys to make sure that you are who you are, say you are, and maintain that state. So basically, we have infrastructure as a service. So, for example, in this case, a good example could be EC2, right? So when you have this huge monolithic application as part of your replatforming, the first step would be to move into your infrastructure as a service, and then once you're there, you think about refactoring that using platform as a service. So in this case, it could be some kind of containers like Elastic Beanstalk or uh, Elastic Kubernetes Service (EKS) that we have, or even if you want to think about going serverless, you could actually think about going all the way into services like Lambda, where you don't really have any servers to maintain. So that is what we call container as a service, and finally, it's a platform as a sorry, function as a service. So once you decide to re-architect, so basically we strongly suggest you to heavily think about moving either your applications all the way directly to containers as a service or even function as a service, right? And one of the biggest challenges on breaking a huge monolith into smaller pieces is how do you orchestrate all of this, right? So think about how you want to do that. Again, a great example we have is
Very
we
good,
have
baby.
services to support that. Sorry, I think I'm hearing. Okay.
Very good,
Oh,
baby. I'm happy.
okay. Hey Ron, are you hearing
Think
any?
about
Okay, I
how
think.
What's that? You
we're gonna
okay?
Are you hearing any background
run
noise?
through
I
the
think
door
I'm
then
hearing
for a
some
couple of minutes.
background noise. Sorry about that.
Okay.
Okay.
Let me turn off. I'm going to turn off Jim. See, there was a little bit from Jim. Okay.
Okay. Sorry about that. But yeah, I think orchestration of all of these services, how do they communicate with each other? Would be your thought about migrating from those old monolithic services into this newer one. So again, your idea of thinking should be you should initially move into, if you do not want to have any friction and you want to have the exact same experience as you have today, infrastructure as a service is where you would go, and then ideally graduate into containers as a service or even function as a service or serverless. So the transformation steps would look something like this, right? The first step would be for you to discover what you have, what are your applications. Then you would kind of design your migration strategy, then develop that. Basically, think about how you can develop that, and basically, it's more like iterative. So you kind of go through that process. So, for example, when you're discovering certain things, few things that you want to think about are what are the things that you have today, right? You have web servers, you have app servers. This is the same example we talked about before. And you have data access services and the database. So what are some of the requirements that these needs to have, right? So for example, a web server should be stateful or stateless. Should you have support for APIs or not? How much storage do you need? Stuff like that. And then you basically map out the corresponding AWS services that are in line with whatever your strategy is. So, for example, if you're having some kind of storage, think about S3. If you're having a NoSQL database support, then think about DynamoDB. Or think about if you want scaling of APIs, think about Amazon API Gateway, right? So things like that are how you want to start your discovery process on trying to understand what you have today. That is your first important thing. So the next step, as we talked before, was design, deploy, and develop, right? So now that you have those architectures, now you have to come up with certain specific needs working with your business unit on should it be API driven? Can your services have their independent databases? Or should they share a database? Because most of the time when you're thinking about microservices, the microservices data should live within the microservice so that you don't have those external dependencies, right? So trying to understand when you're trying to come up with your microservices, when you're trying to break these app layers or any of your monolithic into smaller pieces, try to think about everything being API driven. You will see a lot about this in the web as well when you start to research. It's called API economy, where everything is an API transaction, and each API behind the scene has its own small database. Of course, they also share a huge database just to think about. And again, containerized or serverless, right? There are certain constraints with serverless. So think about containerizing also or going serverless for that application or for that single API. Again, you can have a combination of all of these, right? You can have few of them containerized in your entire application stack. You could have containerization, you could have serverless, you could have a lot more of these that are supported. Again, try to push as many small changes as you can. That way you can have a lot of changes. For example, at Amazon, we release, I think, close to about 1,000 different changes every day. And the nice thing with that is as you release more and more changes, you can collect feedback from the users. If you like it, you can keep it. If not, it's extremely easy to reverse because you now have both the APIs and you can actually go back to the API that has been really great and working. So in scenarios for the federal government and agencies, you can think about your citizen experience, or you can think about your employee experience based on the project and say, okay, this is something that they are liking, or this is something they are not liking, and collect real-time feedback and adjust what you're doing accordingly. And finally, I think it is kind of repeating this process on and on to get more and more feedback and refine the things that are working, refine those individual microservices. Again, the journey might not look the journey is not going to be simple, but I think we have to start it at some point in order to mitigate some of the risks, right? Because sometimes when you don't update these monolithic systems, you're out of compliance and there is a risk of getting that vulnerability being exposed by some kind of hacker or some kind of ransomware, and you do not want to be on the front page of these newspapers for the bad reasons. So think about trying to have a mindset of whenever you're developing a new one, always try to concentrate on doing it the microservices way. If not, try you have to modernize your existing ones. Think about what are the things that I can, if I take this huge application, how can I break that down and get the maximum benefit out of it. So again, it's not just technology. Again, we talked a lot about technology and how it can help you with the migration. We talked some of the concepts again, but remember that this migration of any kind, from modernizing your applications from monolithic into microservices, or for any kind of modernization, it is technology is just one piece of it, but it has a lot more things to do, like the culture of where you are, and with federal agencies that is even more important. And also we want it to be more product driven, and these products could be developing an app, could be a product. So think about it in that way, and also modernizing with things like agile methodologies, which are some of the newer things. Trying to incorporate that into your existing teams will help you to not only think about it from newer products and newer services, but also try to think about it from modernizing your existing applications as well. So at AWS, we have a lot of tools to help you during this migration process, right? So I'll go from the bottom to the top. I know security is extremely important for for anyone, but it is even more important for federal agencies. So we have a bunch of tools that can help you with that, all the way from IAM, which is our identity and access control. So guard duty inspector and stuff, and CloudTrail basically helping you figure out if something changes in your environment. CloudTrail will be able to help you with that. If anything, AWS Shield is an amazing tool, especially when you have challenges of being exposed to hack and stuff like that. So again, all of these tools can be put directly in front of your EC2 instances. So the ideal way is when you are when you immediately re-platform, you can reap all the benefits of something like this. So just by moving into the cloud, like AWS, you can reap all the benefits, like some of the strongest benefits that you have. So that is one of the advantages of moving into AWS is you like there are a lot of credentials that AWS has, and it is vetted out by CIA and lot of federal agencies. So by just moving to AWS and running your same application without making any changes in AWS, you are now going to have all those benefits, and you're going to have to access to this entire tool set. So as developers, you can actually have lot more insight into what you're doing through tools like Cloud9, which is our cloud editor, all the way into X-ray on exactly for you to see what exactly is happening. And we also have application integration, right? So this is again extremely important on how do you interface with multiple different systems. So again, we have application integration tools which help you with that, not just AWS ones. Like if you have any third-party integrations, we actually can support all of that too. And finally, we do also have application, the entire compute data store within AWS. So if you're willing to upgrade, or if you're willing to move your storage into something like S3 or EBS or containerize using Parquet, we have more than that, and we also have serverless database offerings like serverless Aurora. Aurora is our relational database offering, and we have a serverless version of it as well. So specifically for the serverless portfolio, we have some of these as I talked about. So the ones that are highlighted right here in orange are our serverless offerings. So what serverless means is you do not have anything to manage. You do not have anything to manage, and we basically handle everything behind the scene for you. So I know that we are running close on time here, so I'm going to quickly run through some of the design patterns or some of the architectural things that you want to think about, right? So this could be designing with Lambda, right? So in this case, you could have a website where you have a browser, and you could have CloudFront is our CDN. So for things like in the CDC example, we talked about where data is static, and we have certain things about about COVID that they want to publish about the precautions and stuff, you could actually host that in S3 and publish it through CDN. So people could actually access the data very quickly because it is on the content delivery network. It is very close to them. They don't have to come to the web to pull it all over. But if there are metrics on CDC website, like how many cases have been reported, how much, what is the success rate of, and stuff like that in different states, they actually can be do the same, but they actually can use some kind of Lambda or serverless and get the data from behind the scene using either Aurora or Dynamo. And now adding that is our base architecture. Now when we start to add additional security features onto top of it, you now can have things like how are you going to restrict? So all the interactions will happen through certificates, and we also have geo restrictions. So maybe some people from certain countries, you do not want to give access to that. So you can actually have some kind of blockers that way, and you can have bucket policies basically saying who is the only user who can use the files, or who is the only user who can upload the data to some of these, right? So we talked about having the refreshed COVID rates, but how about who can update those new numbers? So having some kind of controls using IAM, which is our identity access management, will basically help you to do all of that. And we also have a lot of integrations. If you already have some kind of identity authorization today, we actually have a lot of integrations into that too. And now that we have added our security layer, we then added we took our base architecture, we added a security. Now we want to talk a bit about monitoring. So how do you make sure that only relevant people are accessing relevant stuff, right? Again, how this is related to modernization. This is how I think you should think about it. Take your base architecture of your monolithic, try to break it into different pieces, and then start to add these layers of security, the monitoring, the networking, and stuff like that. That is how you now can think about not only moving it into a cloud, but also reaping the benefits of being in the cloud. So in this case, for monitoring, we are going to use a couple of AWS services, CloudWatch and CloudTrail. CloudWatch basically will tell you what is going on. CloudTrail will give you who accessed what kind of stuff. Again, now we can do the same thing with containers. In this case, we are going to have something like an ECS, and we are going to have application load balancer in the front. On the second layer, on the first layer, it's pretty much the same because you're going to have static content in S3, which is going to be front-ended through the cloud front. But on the back end, you're going to, for any dynamic content, you're going to have application load balancer. Again, this could be to dynamically changing numbers, like you could get data from CVS, Walgreens, and whatnot into CDC, right? So all that could be behind the scene updated into your databases, and you could have a container engine on the front end, like an ECS, Fargate, and DCR combo to help you get the latest numbers on the front end. Again, thinking about security, on how are you going to balance, or how are you going to think about when two services are communicating, how are we going to authenticate each other? How are you going to make sure they're authorized to do what they say they are authorized to do? And think about it on defining more of a machine-to-machine interactions and human-to-machine interactions, right? Machine-to-machine interactions, all you need is a temporary key or something like that, which will say, okay, this is my key, am I authorized to do this? Whereas human-to-machine interactions, also maybe you can think about something like a graph-based technology where you only get one-time credentials and move from there. Okay, even with containers, monitoring as well is extremely important. So think about monitoring your CPU, RAM for your containers, because again, when do I scale up and when do I scale down, or some kind of things that you want to think about. Again, there are a lot of amazing resources that I will be sending out. I will be sending out this deck to Ron, who will be sharing it. And there are some really good YouTube videos and stuff on your migration path and implementing the microservices, best practices and stuff. So I think that's pretty much it.